all the others, I'm going to do the same review that I do in all my other periods, but yours is going to fast forward what I've been doing in most of my other periods. Mixed natural gases, carbon chain 1 through 4. Yeah. Inherently clean, even though it can bond to contaminants, they would not be a gas anymore. So natural gas is inherently clean because anything that's bonded to a contaminant is not in gas form anymore. The gas is inherently clean. You got this thing with the tower and the weight and the piston and the hydraulic fracturing where you force the fluids down into the rocks and it breaks up the rocks. There's little solvents to make the bubbles more fizzy, and soaps to make them more slippery, and sand to keep the rocks wedged open. So you basically make something that's pretty similar in appearance to the head on a glass of beer. Like not quite shaving cream, but probably finer bubbles than like shampoo kind of. It's kind of like shampoo. You can really go for it with like a lot of shampoo. And that foamy bubbles rise out of the column. You settle that and you pop all those bubbles, and that's the natural gas, and now you're left with a bunch of dirty hydraulic fluid. Did we discuss the 4 actual problems with fracking? Yeah. Water consumption, disposal of hazardous material, secrecy of not really knowing what's in there, and the surface contamination of groundwater. Disposal of all that hazardous material. You've got a lot of fracking fluid left. After all of those foam bubbles pop, there's a whole bunch of fracking fluid left over. Our American capacity for hazardous materials has just exploded. Like, we just turned it up to 48 billion or whatever. Like, the number is like many orders of magnitude greater than we've dealt with until now. And Ryan, to answer your question, not really the earthquakes. So interestingly, fracking is not enough force to create earthquakes itself. You can imagine like kicking a high rise won't make a high rise fall over because the forces don't equal what you would need to move that much stuff. So fracking is like kicking a high rise. Probably not going to make it fall over. Separately, burying all the fracking fluid might make earthquakes more common because you're injecting fluid into porous rock and that'll make it a little more slippery. And so it might make it easier for tectonic energy to release in small quakes. There's evidence that the disposal of fracking fluid might increase the frequency of microquakes. Okay. That sounded completely familiar? Or wait, you got to do something again? Or that was all new to me? Good. Coal bed methane, really common. We got a lot of coal, so there's a lot of methane. So it's simple to get, but we pretty much don't now because it's too dirty because you got a bunch of coal water left over. Right? Mm-hmm. Yeah.
I remember you wanted someone to tell you that we stopped at the world map, I think.
So moving on, there's this cool thing that if anaerobic decomposition happens with freezing, like that, you get methane trapped in ice, which is flammable. It's called methane hydrate. Number 24, 5, 25, 24, 24. And that snow is indistinguishable from other snow. And there are 2 places it forms, the bottom of the ocean or permafrost. You know, where a bunch of stuff just sprouted and grew like crazy and then died and was decomposing when the first snow fell, and then that decomposing stuff froze solid. For the stuff that you have to know, and I don't know if this made it into your notes, they're called deep sea and Arctic deposits. Did I mention those terms before? You have to know them. Oceanic and Arctic, or deep sea and Arctic. Some people call them permafrost deposits. Some people call them snowpack or glacial deposits. But the idea is always the same. The ones that happen up where it's really cold and the ones that happen down where it's very deep. As an energy source, do you all realize that this is not a really good idea? Because extracting and moving snow is not very cost effective to get some gas out of that? Everybody understand that? Like the gas density in snow is like a small percentage, so you're moving $1 billion of cost for a couple $100 of energy. It's not a viable energy source. These are not rhetorical questions. It helps things if you can answer them. Number one, what happens to ice as temperature goes up? It melts. Why do they burn all of the methane at the fireball of death when you're driving a car? Why do they burn that?
Not hazardous.
What's that?
It's not hazardous.
Methane is hazardous, so they burn it to prevent hazard, but it's not just hazardous for you. Anybody know who else it's hazardous for? Maybe we didn't discuss this earlier. Yeah?
Well, isn't it like a climate change problem?
It is a climate change problem, that's right. But when you burn methane, you get CO2. Isn't CO2 a climate change problem? So why do we burn the methane? Because methane is a really big climate change problem. Methane traps that much heat compared to CO2 per molecule. So CO2 is a greenhouse gas, but methane is 10 times worse as a greenhouse gas. Everybody ready for this? Methane's trapped in ice, and our planet is warming up. This is fun if everybody helps me out. On a warming planet, what happens to all the methane hydrate? It melts. And that releases a whole bunch of
Methane.
into the atmosphere. That's right, thank you, this is fun. And all that methane, when it's in the atmosphere, does what to the temperature of the planet? Rise, makes it hotter, heats it up. On a planet with rising temperatures that are heated up, what's going to happen to all the remaining methane hydrate?
Melt.
And that'll release more,
Methane.
which will make the planet, which will melt more, releasing more, make the planet more. So you all know that a cycle whose outcome is more of that cycle is called a positive feedback. And methane hydrate is considered to be like the critical temperature, holy crap, climate moment. This will be mentioned again when we discuss the atmosphere and climate. But now that we're talking about methane as an energy source and as a greenhouse gas, it seems like the right time to just kind of give you a heads up it's coming. There's a lot of research into what happens as the planet heats up. Here's a crazy idea. Canada has like really well-funded science and public outreach. So they've got this ridiculous notion of educating their public about real problems. So someday if you're bored and you want to see how this works, you should Google climate permafrost documentaries. And the Canadian government, working with a bunch of nonprofits, have been issuing this series of documentaries about how our planet changes as permafrost thaws. It's really interesting, it's fascinating. For one thing, they're finding a whole bunch of archaeological sites. So right now, there's like a wave of hiring for alpine archaeologists. People who go do archaeology at like high elevations at the foot of glaciers and a bunch of down gear, like crampons and like, ice axes to go do archaeology. There's also a rise in like I forget the word is for frozen autopsies. People who find frozen bodies and have gotten really good at autopsying human remains, because a lot of 600 and 800 and 2,000-year-old bodies are all showing up in the ice, and that's pretty amazing. There's also a fear that diseases can survive freezing and thawing. They've checked, the plague does not, but other viruses do. So as the permafrost melts, there's this fear that ancient diseases will come back, and we're not ready to see a wave of new diseases right now. And in case you're curious, there's a rad television series on Amazon Prime that I think is Icelandic or Norwegian. Anybody ever seen Fortitude? Okay, like 5 stars, like key good media. If you're into screen time, you gotta look this up. It's on Amazon Prime. It's called Fortitude. You should write that down. It's unbelievable. It is beautiful and dark and macabre and spooky and like kind of humans behaving badly, but like really scenic and beautiful film work. Oh my God, Fortitude. And as if all that stuff wasn't bad enough, the permafrost melting is going to release tremendous volumes of methane, which makes a lot more global warming than humans have made. The potential for methane to warm climate is some orders of magnitude greater than what humans have been responsible for in the last 100 years. Okay. Anybody want to talk more methane hydrate? You study it. Get ready to write number 25. For the good kids who do their homework, you're going to put some stars on your notes. I know that most of you fake it. On number 25, the good kids have a list of environmental effects of oil and natural gas extraction. That was the study goal, number 25. And for the good kids who actually read the book, you have 1 through 8. I'm going to add 9 through 12. But 1 through 8, in case you want to check, land use for the pads and the wells, surface water and groundwater pollution, accidental release of air pollution like hydrocarbons, land subsidence where the holes were, loss and disruption of fragile ecosystems, oil seepage into the sea, drilling muds that contain a lot of gnarly stuff, and aesthetic degradation. That was 1 through 8. Just checking, how many of you actually had that list? That's about the number of kids I thought would have that list. Okay. If you don't have them, take my advice, write yourself a little note to get them out of your book later, because that's a 2-star study goal. Now I'm going to add 9, 10, 11, and 12 to your list of 8. Problem number 9, which your book did not mention. Petroleum tankers are really, really, really dirty. There's a lot of them. They have to travel really far. They're usually really old. They go a long way on a single trade stop, so you don't need a lot of crew. So there's just kind of like a couple of people driving this gigantic thing all the way from the Persian Gulf to Houston, and then they stop once, and then they go drive all the way back to the Persian Gulf somewhere. So they run like very small crews, and that's kind of important to know. Those tankers use the dirtiest fuel of any other fuel type. Tanker ships are by far the dirtiest because, you know, they're not burning fuel next to humans, so they're not subjected to air quality standards. Do you know that the single biggest threat to Santa Barbara air quality is the shipping lane, the shipping channel out in the ocean out there? They're the #1 contributor to our air quality problems. Worse than all the cars or all the houses or all the factories of Santa Barbara, it's the tanker ships out there. It's not even that many of them, and that's still our biggest problem. Here's problem #2, and this one's kind of tough to explain, so you'll have to bear with me, okay? This bottle is empty. This bottle is full. Okay. If I drop these two in the ocean, there's a difference in how they float. Everybody agree with me? Because this one's mostly full, it has a little tiny air bubble in it. This would probably float like right like that, like just below sea level. Agreed? And this one, which is empty, will probably bob around the surface of the sea. Everybody understands this concept, I think. Coming from the Middle East, a petroleum tanker is like this. It's full, so it's massive and heavy. It floats, but it rides pretty deep in the ocean. So it's held by Neptune's loving embrace. So if there's like waves and storm and wind, it's pretty safe because, you know, the boat is hugging it. Sorry, the ocean's hugging the boat. Does that make sense to everybody? That the tanker ship coming from the Middle East is pretty stable and safe? Yep. Shows up in Houston, goes, squirts out all the petroleum. Now he's empty. So he's floating on the top of the sea. You can tell if they're empty or not because it'll be like much bigger or right down to sea level. People who spend time in the ocean will tell you this. And that empty tanker ship has to go all the way back to the Middle East, bobbing around like a cork. Imagine that this captain's dreaming of seeing their husband or wife when they arrive back in the Middle East somewhere. But between them and their beloved is an oncoming storm. What's that captain gonna do to stabilize their ship? What would you do?
Take on water.
Take on water on purpose, right? I wonder where a petroleum tanker could fit a whole bunch of water.
The petroleum tanks.
Bingo. There's a term that you have to know for this. Ballast is the weight that a boat uses for stability. Ballast. You may know that like galleons, Spanish galleons used to just carry boulders to stabilize themselves crossing the ocean when they didn't have a lot of cargo. It's called ballast. Now that thing I mentioned about the salt water going into the petroleum tankers, you also need to know that that's illegal. It is explicitly against the law. But you got like 5 bros on the boat and you're in the middle of nowhere and life or death storm is coming and your boat's just like bloop, 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 or, you know, just bobbing around. You know, like, guys, are you afraid? Because I'm afraid. And everybody's like, yeah, we're all afraid. And it's like, you guys want to go for it? You know it's illegal? They're like, I just want to get home, man. So they just put a whole bunch of salt water into the petroleum tank. And then when they show up in the Middle East, you know, they don't need that salt water anymore. So where does it go? Along with all the funk that was in the tank. There's like a lot of solutions. A, you could make laws, we have. B, you could have different ship designs. So most ships of that scale have ballast chambers that are not the petroleum tank. And C, if you want to save the tanker capacity for the tank, then you could use a liner. So that you fill up the salt water in the liner and you put the petroleum between the tank and the liner when the liner's empty. It's like having a balloon hanging inside this bottle. I can either fill the balloon or I can fill the bottle, right? So there's ways around this. It's not like this is rocket science. But those tanks are really old, those ships are still out there, lives are at stake, everybody wants to get home safe. This happens a lot. You know what's crazy? When you do the math, that is still the #1 largest input of petroleum to the sea. Let me put that into perspective. There is more petroleum in the sea from ballast of tankers than all the natural seepage, plus all the atmospheric deposition, plus all the oil spills and accidents, plus all the surface runoff of the planet. That is still smaller than the amount from ballast, and also from the bilge solution of boats. You should probably know that too, ballast and bilge.
What's bilge again?
Any water dorks here? Ocean dorks? Sailors?
The lowest part of the boat.
Lowest part of the boat, yeah. So inside every boat there's a low point, and any fluid in there is called bilge solution. And any drips from the engine or any like slop from the deck, that all gets in there. And the whole job of a boat is to keep the ocean on the outside. If you fill your boat with ocean, it's not a boat anymore, it's something at the bottom. So boaters have these things called bilge pumps, which empty the bilge solution so you keep the bilge dry. And on an oil tanker, that's pretty funky, and that goes into the ocean too. Okay, so number 9. So number 9, tankers are filthy. They use the dirtiest fuel. It's illegal, but they pollute the ocean with ballast water. And because of their scale, their bilge water is pretty nasty. Problem number 10. You have to refine petroleum. The petroleum you get out of the ground, I mean, if you kind of want to imagine what it's like, you got a barrel of asphalt, and then you pour some roofing tar, and then you pour some diesel, and then you put some jet fuel, and then you put some tanker fuel, and then you pour some gasoline, and then you pour some water, and there's some little like natural gas fizzy bubbles in there. And then you pour some like white gas or kerosene on there and like mix it all together. That's petroleum coming out of the ground. You got to separate all of those things. So vocab alert. We refine petroleum through a process called fractional distillation. And this is kind of tough to explain. Keep in mind, I've got students at AP Physics to never physics level in this class. So some of you already know where I'm going, because you can just break down those words. How many of you think you know exactly where I'm going because you can break down those words? Just checking. Right. Unfortunately, a lot of my other students don't, so I just got to see if I can't walk everybody through this, okay? You make alcohol and beer by feeding sugar water to yeast. Those yeast will take that sugar, break it up into, anybody know? No? Well, yeah. Alcohol and CO2. So that's why beer has alcohol and bubbles, because CO2 bubbles. And that's why bread has bubbles. Those are little yeast parts. And there's also alcohol mixed in. In your sugar water, the yeast will eat up all that sugar water until they've made so much alcohol that they get drunk and they die. The yeast cannot produce more than about 14% alcohol. That's why sake, really alcohol-rich beers, and wine all have an upper limit on alcohol, 14, 15%. But I'm sure you all know this, 14, 15%, who has time for that, right? If you want to get all crunked up at a party, you can't do like 14 or 15%. So how do we make stuff like whiskey and rum and vodka that's 40% alcohol? No, fermentation has an upper limit. After about 14% alcohol, the yeast die. So if you have like 1,000-year-old sake and you open the barrel, it's still 14%. The yeast all died after that. You maybe didn't hear that there's like a hipster revival of like craft small-scale moonshine production? And we got to figure out what those dorks are doing to understand what we're going to do with this petroleum. How do you take alcohol out of the water? They look the same. They're both a clear fluid.
Distillation.
How does that work?
Different things
They have different evaporation points.
You heat it up, but because those different substances have different evaporation points, different boiling points, as you raise the temperature on your bathtub, that's why moonshiners use bathtubs. Because old school bathtubs are claw-footed and they're iron, so you can light a fire underneath. So, you light your fire underneath the bathtub, and your wine or beer starts to get warmer and warmer and warmer until, listen carefully, this is the key point about this. For those of you who don't speak chemistry, not all things boil at the same temperature. In the case of beer, which boils first, the alcohol or the water? Alcohol boils first. So you put a tarp over your bathtub, hope it doesn't catch on fire and burn down your cabin. All of the alcohol will condense on the underside of the tarp. You let it run down into your funnel, into your jug, and Daddy has his medicine. Because different substances have different boiling points, the different fractions of petroleum can be distilled as the petroleum's temperature goes up. We do this at gigantic scales, like square mileage of refineries. Please look up. At different seasons, somewhere between 25 and 50% of America's petroleum is refined in the Houston area. Which is basically a whole field of plumbing and tanks and tubes and pressure valves and brake knobs and dudes in hard hats. And these really, really, really big towers that are all heated up. You got to know this. The short chains are already gas at room temperature. C1 to C4, you already know, are gas on their own. The natural gas will bubble out before you add heat. Then, please look up. Add a little more heat. You get all the C5 to C9 to evaporate. You use something which is not a tarp but works like a tarp to take that gas aside. You cool it so that it condenses into liquid. That's called naphtha. And that's what we make all of our plastics and industrial chemistry out of. Then you raise the temperature a little higher and up to C10 will evaporate. That's all gasoline. And you put that into gas trucks and you drive it around to gas stations. And then you raise the temperature a little higher and all the paraffin and kerosene will evaporate. You condense that down to liquid. That goes in different tanker ships to heat houses in the Northeast and to run jets and stuff. Get it a little hotter, and then all that gas gets condensed back into bottles, goes into diesel. You get it even hotter, and you get all the lubricants. You get it even hotter, and you start to boil all of the fuel for factories and tanker ships. And then the last super thick boiled goop in the bottom, that's tar and asphalt. I need to stress in number 10 on your list that the refining of petroleum is extremely dirty. It's super dangerous, sketchy for the workers, the plumbing leaks. You've got every type of petroleum product boiling up to gas, then being cooled down to liquid. Like, what could possibly go wrong at that spot? Like, imagine walking around at work every day with evaporated gasoline on your right and evaporated diesel on your left, and natural gas being pumped around through another big set of pipelines, and trucks moving back and forth with tankers and like huge flame of death lighting this thing up. Like, this is nar. This is some really, really dirty stuff. Somebody had a hand, by the way. Yeah.
Oh, I was gonna ask, is there any like one of these that's more valuable? Like which?
Market rate would tell you, but you know, like, it's basically supply and demand stuff. So when there's greater, the gasoline values tend to drive petroleum, and vice versa. In the United States, because we need so much gasoline, everything else is relatively cheaper because we have like a glut of the other distillates in order to feed our increasing demand for gasoline. In the winter, there's like a spike in the need for heating oil and kerosene. There's probably a shipping season where I think we're going to need more fuel for tanker ships. And so there's strategic reserves that kind of buffer out those price spikes. So you kind of just average out the price to general availability. In the US, we can produce most of these, but the petroleum blend really low in gasoline is the one that we have. So we have to import petroleum blends that are really high in gasoline and low in the other stuff. Then imagine problem number 11. All these things have to get shipped around the entire planet. Like, all that jet fuel has to go to all the airports, and all the tanker fuel has to go to all the ports. All that gasoline and diesel goes on trains and trucks. All the natural gas is carried through pipelines. When I started teaching this class, I never really noticed how often there are horrific accidents involving a petroleum product. Last 15, 16 years, I just kind of like watch the news and it'll be like, oh, natural gas pipeline erupts next to preschool. Children mangled, flames everywhere. Or like jackass rolls gasoline tanker on the freeway. Like, for some reason, they always do that on the Milpas off-ramp. On the southbound Milpas off-ramp. It's like nonstop. I don't know how many times I've been coming to work. I used to drive down Highway 154 and I would take the Milpas exit back in the day before they did the new rerouting. So a couple times a year, like, oh, you can't go that way because they got all the sawdust out because another gas tanker rolled off. That's probably got to be the most gasoline polluted soul in Santa Barbara, is the southbound off-ramp on Milpas. Think about what a hazard it presents. That every type of petroleum product is dangerous. Dangerous to groundwater, surface water, air quality, flammable / explosive as a gas. And we got all these things traveling around at freeway speeds or on the train tracks. Then finally, problem number 12. There's all the air pollution when you light it on fire. That's the one that we talk about. You find a random on the street and you're like, yo, what's wrong with gasoline? And they'll be like, air pollution? Sometimes they'll say climate change, sometimes they'll say smog. got a story to tell you. I have 2 uncles. One of them is lovable crazy. The other one is just not very lovable crazy. This one of my uncles is kind of a jerk. He's just like mean to people. And that's the problem that we always talk about. Like he'll come over for dinner and then like all of my Argentinian family will be like, oh man, that guy, he's so mean. We don't really talk about the fact that he's kind of a crook. Like he's a businessman and nobody wants to do business with him because he's just a shady businessman. You know something else that we don't talk about? He's a womanizer. He's divorced because apparently he cheated on my aunt like 100 million times. And we don't talk about the fact that the guy drinks way too much. And he smokes too much. And he's like morbidly unhealthy because he eats way badly and way too much. Apparently he was also kind of like a malicious and I think sort of violent father to my cousins. And every time he comes around like a family reunion, you know, his family's family, everybody's still happy to see him, you know. Then you leave and everybody's like, man, did you notice how mean he was at the table? And I'm like, yeah, but couldn't we talk about all the other problems? Anybody know why I'm telling you that? Because number 25 is all the other problems with petroleum. We always talk about the air pollution and the smog and the global warming, and that's real. But even if you could just miraculously solve global warming and you could miraculously solve smog, petroleum is still horrible. You got a list of 1 through 8 and I gave you 9 and 10 and 11. Before number 12 you burn it. You understand how my uncle's story is relevant? Okay. Number 24. This is the first year that I have a different punchline for you. Yes?
Wait, we just did 25.
Oh crap, yeah, I got my numbers wrong. 26.
Okay, thank you.
I'm using my own notes, sorry. Number 26. I'll explain later, but my notes are different. There is this place in Alaska called the Arctic National Wildlife Refuge. It's right up there. So I don't know if you can see this from where you are, but in the upper left-hand corner, you see most of Alaska in a green silhouette, and the yellow northeast corner of Alaska is called Anwar. It's a wildlife refuge on the border with the Arctic Ocean to the north, and then Canada to the east. Alaska, yellow, this yellow thing, that's Anwar. And there's the ocean, and there's Canada. For years, the Arctic oil fields on the Alaska side have been very productive. And all things considered, like pretty successful. A couple of horrific accidents, but otherwise really nice. Northern Alaska, Arctic Ocean stuff. And then Canada side, that's where Canada gets a bunch of their petroleum. Really, really, really successful for Canada. And there's been this conflict with like, whoa, all the wildlife and whoa, all the petroleum potential. I've never been up there. It's really tough to visit. As a wildlife refuge, it has very, very, very limited access. So like, you can walk in and you can probably hire a snowplane to land when there's snow. I'll assume you can boat in, but you're in the Arctic Circle, so that's not easy. I'm sure you can walk in, but I don't know that there's many roads at all. There's like special use limited access roads only. It's super remote. you can imagine that, let me go back to the map. In that part of Alaska, you've got all the mountain ranges of North America tapering to the coastal shelf, like that. So this is where like all the permafrost, seasonal change, blossom, migratory stuff. In the winter, everybody knows it's just snow. And then in the summer, the wildlife is just thick. Like those petroleum sites up there, they have like pretty unbelievable wildlife access. Now, here's a map of Anwar again. It's outlined in yellow. And if you look up in the, can you all see that little cursor moving? Up where it says 1002 area? See that thing moving up there? Oh, I make it bigger. Oh! Okay, right there. Do that. Okay, up there. This is called the 1002 area, and that's where they want to drill. It's super unfortunate because right in that little tiny part is a teeny little native village. Actually, a native area that includes a village and a bunch of native managed land. I'm afraid I might get this wrong. Koktovik Inupiat. And I probably got that wrong. There's a whole bunch of federally managed species in that area. Fish. My wacky TA who made the slideshow just put a picture of a fat cat for you. And you can see that. Where's that cursor? Oh, I lost the cursor. See, I didn't think I could do that. Okay. In the Anwar thing, this is that little area that they want to make accessible to drilling. And that includes the area which is native managed. You can see already that there's a bunch of development to the west and a bunch of development to the east, and people want to just kind of get this last little bit. This is going to be the most drilled area, coastal plain. And of course, there's a lot of concern about wildlife. Fun detail, apparently natural gas pipelines are warm because the natural gas is compressed and it's pumped. And so they're much warmer than the environment, so apparently bears like to take naps on pipelines. And I guess you can Google grizzly bear napping on pipeline, and you know, they're round and bears are clumsy and deep sleepers, so when they take naps they fall off the pipelines and it's really adorable. All the environmentalists are worried about the impact of all the petroleum extraction. A lot of petroleum types say, no big deal, it's just snow and ice, who gives a crap? And part of the year, that's kind of accurate. The environmentalists say, well, what about the bears, man? They're migratory. And then all the petroleum guys are like, yeah, but bears love pipelines. Look at this video I found on YouTube. Isn't it adorable? People say, it's just a little bit of Alaska. Who even cares? Nobody uses it. Watch your statistics. When people talk about how many people live there, they'll often say how many. There's a way to say it so that you don't count Native Americans who live there. You can see that when it's snowy, it's really pretty snowy. And of course, when it blossoms, it goes off. The ice road thing is interesting. Do we count the surface area of ice roads or not? Because the ice road's not permanent, but it's not necessarily passable to migratory animals because it's hardened ice. Do we count that whole parking area, or do we count the area of the well site? I gotta tell you, there's been this really amazing debate. About Anwar, but all my previous years, you know what I used to tell people? Sooner or later, we're gonna have to drill Anwar because we're gonna run out of other petroleum, and I bet you money we're gonna get some kind of president that wants to drill Anwar. Anybody know the punchline to this? This story?
We're not drilling it?
Yeah, we're green lighted for drilling now. It was not relevant to the current budget, but to get the Alaska senator to pass the budget, they said, okay, fine, you can go ahead and make a ton of money in Alaska, and you can drill Anwar. So we've just opened up a wildlife refuge, which is nationally protected land, to petroleum extraction. This just happened this December. People have been trying to drill it for a really long time. We could probably get about 3% of our gasoline needs here, which is huge. That's a big percent. One statistic that you should probably know, the total footprint of the drilling is 2,000 acres, which is half of 1% of Anwar. Doesn't sound like much. But all the hippies say it's 1.5 million acres. How can these both be right? Is it 2,000 or 1.5 million acres?
Stuff is like frozen over.
Kind of.
Overall impact?
Overall impact, exactly. This is just one proposal, so the proposals will continue to change over time. If you measure the black dots, that adds up to 2,000. If you measure the area connected by roads, plumbing, power lines, fence lines, and so on, if you can measure some impact, that's 1.5 million. So both of these numbers are accurate. It'll be 2,000 acres of well pads with about 1.5 million acres of what we call development sprawl to make that happen. Sorry, I didn't have a slide for this. This could be, you know, it might end up with a different plan, but this is the most official. Okay. I want to stop here to make sure that I get my my other classes up to the same speed. Are there any questions about anything I've said so far today? Yeah.
What was the Walmart?
Thaw, growing, and freezing.
Thaw what?
Permafrost thaws, it sprouts, and it freezes. Darren, could you stop the recording, please? Or the streaming? Children, anybody want to ask me any questions about the Anwar situation? We live in strange times.